This is the world's most expensive cargo ship. Constructed over 2 years, it cost over $200 million to build. It is also the most difficult civilian ship to build. Only 13 shipyards in the world are licensed to build this ship. It has only one mission: to transport an environmentally friendly fossil fuel that can power modern cities. This fuel makes everybody's life simple. But the construction of the ship to transport this fuel is not simple at all. A single mistake can lead to disaster. The biggest shipyards and the best marine engineers come together to carefully build this giant ship with the most advanced technology in the world. They make the impossible possible. A giant, mysterious ship is pulled into the harbor by 4 towboats. Apart from the towboats, there's not a single ship around it. There's no cargo on the deck of this giant ship. This is an LNG carrier. The 3 big letters painted on the ship's body, LNG, stand for liquefied natural gas. They remind the ships around it that the cargo on board this ship is extremely dangerous liquefied natural gas. All the other ships should stay away to prevent collision. In its own dock, the LNG carrier is transporting the LNG through specialized pipelines. The fuel is temporarily stored in a gas tower by the harbor. On the other side of the harbor, a large tanker truck is already waiting. It will transport the LNG to the city. The world. Shanghai, the biggest city in China, is experiencing rapid economic development. At the same time, environmental problems are becoming a concern for its people. Thanks to the effective and environmentally friendly natural gas, this city is able to develop without any worry. In 2012, Shanghai requires 4 billion cubic meters of natural gas. But there is no naturally occurring natural gas to be found here. Just like petroleum and coal, Natural gas formed when prehistoric organisms underwent chemical changes over millions of years. Although it is found in many parts of the world, its distribution is not even. At the moment, Russia, the Middle East, and the South Pacific hold the world's most natural gas reserves. Transporting natural gas from countries far away is not an easy task, until a new method was invented. When cooled to -163 degrees Celsius, natural gas condenses into a colorless, odorless, and non-toxic liquid, that is LNG. Its volume becomes 600 times smaller in its liquid form than in its gaseous form, reducing the costs involved in its transport. For Shanghai to develop smoothly, it needs a regular and steady natural gas supply. For that, it will have to build its own LNG carrier. But not every shipyard can build an LNG carrier. The liquid must be kept at very low temperatures because it is highly flammable when vaporized. Any flaw in the ship's design can result in a catastrophe. On the 20th of January 2004, there was an explosion at an LNG liquefaction facility in Skikda, Algeria. A vast area of the facility was destroyed. 27 people were killed, 72 were injured. The painful lessons of these accidents mean that every engineer of an LNG carrier treats his job with the utmost care and dedication. Dawn by the shore of the Huangpu River. Every day, more than 5,000 workers walk through these doors. This is an immense shipyard. It produces 2.2 million tons of ships every year. More importantly, it is one of the 13 shipyards in the world licensed to build LNG carriers. This means that it has one of the highest standards in shipbuilding in the world. Now, this shipyard will take on the duty of building the safest LNG carrier for its own city. This LNG carrier will be 292 meters long and 43.35 meters wide. Its deck area will be the size of 30 basketball courts. It will be able to transport 174,000 cubic meters of LNG at any time. That is enough to provide the 23 million residents of Shanghai with 1 month's worth of energy. Work has begun on Shanghai's own super-sized LNG carrier. The engineers in the project will spend the next 2 years carefully building the safest LNG carrier in the world. To build this massive ship, the shipbuilders will make considerable use of prefabricated sections. This massive ship will be divided into 264 different sections. These sections will be built separately and then assembled together with the utmost precision. The first step in building an LNG carrier is to cut the steel plates. But this does not take place on the shipyard floor. This takes place in the design department. Before construction work even begins, the engineers have to calculate and design every single plate of steel on paper to make sure that every one of them is perfect. On the 20th of March 2010, the first steel plates are transported to the shipyard. In the next 5 months, the workers will have to refit 6,000 steel plates into over 100 different categories. They will be cut into different shapes and welded to form the ship's body. The minute a steel plate arrives at the shipyard, its destination on the ship has already been predetermined. For the workers, there can be no room for mistakes. The first thing Xiaoxi does every day is to check the steel plates. On the side of every plate is a unique barcode. This barcode contains information on its format, the date it was received, and the person in charge of it. This ensures that every single plate is used according to plan. These data will follow the steel plate through every step of the way. Xiaoxi carefully checks the steel plates against her data diagram. She must cut each plate with a certain exact speed and at a certain temperature according to its thickness and firmness. If a steel plate is not cut according to regulation, it might result in an accumulation of errors, endangering the safety of the entire ship. Mr. Zhang is operating a huge milling machine. This machine is used to refine the edges of the steel plates. According to regulation, a 17-meter steel plate has to be filed down to an accuracy of 1.5 millimeters. This is the same as saying that the vertical of a wall in a 6-story house cannot be displaced by a single millimeter. If the steel plates cannot be welded together properly, there might be leakage on the ship. And leakages on an LNG carrier can be lethal. After 2 months, the cut steel plates are inspected once again and are moved to the next phase. These steel plates will be welded together to form different parts of the ship. This is a complex and tedious job. These fully automated welding robots can improve work efficiency threefold. The most unique thing about this is that there are no sparks during the welding process. Before the welding process, the robot will discharge powder to contain the sparks. Not only is this safer, it ensures the quality of welding, and it's good for the environment. The LNG carrier emerges from the steel plates. One can finally see the different parts of the ship on the floor of the shipyard. The shipyard floor can no longer accommodate the different parts variously weighing 40 to 100 tons. The engineers will now need more space to assemble the parts together. They will have to move to the dockyard. The different segments of all shapes and sizes are transported from the floor to the dockyard. The order in which they are transported has to be carefully calculated.
Most of the LNG segments are made from 17-meter steel plates. The final segments are all around 17 to 18 meters long. The length of segments for regular ships is usually limited to 12 meters, but LNG carriers need to be heavier and bigger, so we have to use much bigger trucks to transport them.
One of the biggest challenges is transporting these huge parts within the shipyard. Mr. Zhang's job today is to transport a welded LNG carrier segment to the dockyard. He drives a flatbed truck. Thanks to a specially fitted hydraulic setup, this truck can carry weights 10 times heavier than what a normal truck can carry. This special flatbed truck also has a unique capability. Every set of its wheels can rotate 360 degrees. This unique capability helps it to maneuver around easily within the shipyard. It is not easy driving this truck. Mr. Zhang's cabin is fixed below the flatbed. One of the problems of this design is that it means that he has blind spots to his right, left, and back. He needs to rely on the directions of the safety officers. With everyone's help, the massive segment is finally transported to its designated area. Together won't be an easy task for the shipbuilders. These segments are enormous and weigh thousands of tons each. During the assembly, the margin of error cannot exceed 3 millimeters. It is time for the gantry crane to shine. At the end of the dockyard are 2 gantry cranes, each with a capacity of lifting up to 600 tons. Together, they can lift a 1,200-ton segment for assembly. Mr. Xiao is in charge of the team in the dockyard. The first thing he does when he comes to work every day is to go up to the top of the gantry crane to supervise the operations. He needs to make sure that the gantry cranes are functioning normally. If there is an error in any of these cranes, the assembly of the LNG carrier will be slowed down. Every day of delay translates to massive losses for the company.
The function of the 700-ton gantry crane is to hoist and assemble ship parts weighing over 40 tons in the dockyard. We have to rely on our 2 gantry cranes for this.
More than 10 meters up in the air, Xiao Jin is operating the gantry crane to hoist the different parts into place. The construction of an LNG carrier is not like that of a regular ship. Everything needs to be very precise. The body of the LNG carrier is made out of enormous steel plates. Every part of the ship is much bigger than a normal ship. Xiao Jin needs to assemble these pieces with a margin of error that does not exceed 3 millimeters. Every day presents a new challenge for him. Even a slight tremble in his fingers can result in an inestimable disaster. It is a sunny day today, but the storm that happened yesterday is weighing on Mr. Xiao's mind. All the workers are coordinating the assembly today. Mr. Xiao signals for the entire operation to stop, but there didn't seem to be any errors in handling this part. This makes Xiao Jin nervous. Mr. Xiao gives Xiao Jin a new order. The part is to be flipped vertically. The water from yesterday's rain had gathered in the part and has to be poured out. This water would have created problems when the part was welded later. Now that the water has been poured out, the part is moved slowly to its designated position. After it has been put in place, the quality inspectors examine the part carefully to make sure that every connection point is at its right place. After 3 months of intensive work at the dockyard, this enormous LNG carrier has been assembled. But more important tasks lie ahead. The purpose of the ship is to safely transport natural gas that is liquefied at -163 degrees Celsius. That means that the most important parts of the ship are these 20,000 pipelines. These pipes form a closed circuit in which the LNG can flow safely and securely. In order to move a ship weighing 150,000 tons after LNG is loaded on board, the boilers of the ship need to be extremely huge. The liquefied natural gas in the LNG carrier will vaporize during its transportation and return to its gaseous form. Natural gas that has been vaporized needs to be released, or the cabin pressure will dramatically increase on board the ship, creating a massive safety hazard and endangering the crew. Instead of releasing this boil-off gas into the atmosphere, the ship recycles it and uses it as fuel. This takes care of the safety hazard and saves on the fuel needed to power the ship. To do this, the LNG carriers have dual fuel boilers that can run on either oil or natural gas. This is the only type of cargo ship that is permitted to use its own cargo for power. The 2 steam turbines produce high-pressure steam at high temperatures. This steam is fed to the engine through temperature-resistant pipelines in order to propel the LNG carrier forward. Every temperature-resistant pipeline has to withstand temperatures of up to 518 degrees Celsius and steam of up to 60 kilograms. The quality of the pipe's material and its welding need to be of the highest standard. All the pipes are made from a special steel that can withstand high temperatures and high pressure. Before they are welded together, the welding points have to be heated to 100 degrees Celsius. This temperature must be maintained throughout the entire welding process. On the deck of the carrier, another type of pipe is being installed. They are the complete opposite of the high-temperature pipes. These low-temperature pipes are an important part of the system that contains the LNG. The pipes are connected to 4 cargo holds. Through these low-temperature pipes, the LNG is pumped to the ground-level storage tanks. Regular steel will become brittle and fragile at -163 degrees Celsius. The special steel used in the LNG carriers can perform under these extreme temperatures admirably well. But it is a challenge to weld this type of steel. The pipes are first welded together, segment by segment, on the shipyard floor. This is Chi Dong. He is the expert on welding low-temperature pipes. His specialty is welding with both hands.
焊接应该大部分焊工他不会，为什么呢？大部分焊工技校毕业，他比较规范，都是右手。因为我是退伍转业回来的，转业回来以后，我就像一张白纸一样的，没有接触过焊接，所以那个时候也是抠喇叭，2只手都来。然后师傅看到了就说保持好，然后一直保持到今天。
When the shipyard started building LNG carriers, Xiaodong's left-hand welding technique finally came into play. The welding area of the low-temperature pipes is very small. Most welders can't fit their right hand in the space allowed, let alone begin to weld. Using one's left hand fixes this problem immediately. Welding with both hands might strike one as impractical and showy, but it has become an indispensable technical skill in the construction of LNG carriers. On the welding floor, 2 workers stand out. Their job is to take X-rays of the welded points. They have very strict standards for this. Every section of the pipeline and every welding point needs to be examined individually and carefully recorded. The X-rays are sent to a lab for processing. Once the processing is finished, humans actually discovered and started using natural gas very early on. Records show that 1,000 years ago, China was already using natural gas to fuel the extraction of salt. But up to the 1980s, natural gas wasn't a commonly used fossil fuel at all. The biggest reason was because it cost too much to transport large amounts of natural gas. This all changed when the technology to liquefy natural gas was invented. This technology involves cooling down natural gas to -163 degrees Celsius, causing it to liquefy. In its liquid form, natural gas is 600 times smaller in volume than in its gaseous form, greatly reducing the cost of transportation and storage. In today's rapidly developing China, the need for more energy is increasing. The traditional energy sources, coal and petroleum, cause damage to the environment and are now widely derided. As for other energy methods, there is still a measure of suspicion towards nuclear energy. Wind and solar power technology are still not fully developed. The only reliable and environmentally friendly energy source left to us is natural gas. It has become the one source of energy that Chinese society depends on. This LNG carrier will transport liquefied natural gas 2,000 kilometers across the sea to Shanghai. It can transport up to 147,000 cubic meters of natural gas at one time, enough to provide 1 month's power to Shanghai's 23 million residents. Building a ship like this is not just important to Shanghai, it will also serve as an example for future LNG carrier construction. Work on the LNG carrier has been going on for 10 months now. The ship has now left the dockyard. It is now berthed in a special dock, a sign that its basic structure is complete. Now the cargo tanks will have to be installed on the ship. When a brand new LNG carrier is finally berthed in its reserve dock, everyone working on it knows that the most difficult and the most crucial stage is about to begin. 4 cargo tanks are about to be installed on the ship. This is the phase that involves the most advanced technology and presents the highest difficulty in the building of the ship. Half of the $200 million that go into the building of this LNG carrier will go to the building of these 4 cargo tanks. The insides of the LNG carrier cargo tanks are fitted with 2 layers of insulation to ensure that temperatures inside remain at -163 degrees Celsius. Every layer is built with thick insulating material and a 0.7 millimeter Invar membrane. The insulating box isn't just a simple wooden box. It is made from special plywood imported from Indonesia. This wood is strong, durable, and doesn't warp easily. The workers will then fill the wooden box with perlite that has been ground to powder. Perlite is a great insulating material. The factory in which these boxes are manufactured uses the most advanced production line in the world. There are 1,100 different kinds of insulating boxes that are used on different LNG carriers, totaling 55,000 in the world. Every box is manufactured with the highest quality standards. The strain rate of every insulating box must not exceed 0.06 millimeters. This margin of error is even smaller than the diameter of a single strand of adult hair. Only the most advanced automated technology can ensure such a precise standard when manufacturing in bulk. Lining the outside of the box is a 0.7 millimeter membrane made of Invar, a rot-resistant material that can withstand extremely low temperatures. It can safely insulate the liquefied natural gas at -163 degrees Celsius. This makes the Invar membrane the ideal material for an LNG cargo tank. The modified Invar is wrapped carefully in a plastic membrane to keep it safe. Invar is vulnerable to certain things, one of which is water.
Invar rusts very easily. If we don't wear gloves and we touch it with our bare hands, it'll rust immediately. If it's allowed to rust further, we won't be able to wipe it off at all.
Invar is so susceptible to water damage that even a single drop of sweat can leave a permanent rust mark after half an hour. The chemical properties of Invar will change if it is rusted. This becomes a safety hazard if it is employed in an LNG carrier.
If any vapor escapes the tank, the safety of the entire ship will go down the drain. It'll become extremely flammable, and the ship just might explode.
To ensure absolute safety, every worker who enters the construction space of an LNG cargo tank will have to go through 2 safety doors. They must observe the strictest regulations. They cannot bring in any water into the tank. The welders have to wear lambskin gloves that absorb sweat. All these precautions exist to create a moisture-controlled environment. These 4 cargo tanks will hold 147,000 cubic meters of liquefied natural gas. At the construction space, workers have erected a 10-story high scaffolding. There are 10 faces to the inner wall of the cargo tank. All the faces need to be covered in insulating material. This is an enormous and complex steel structure. The entire structure is made from 69,600 parts of 990 varieties. There is even an elevator that facilitates the transport of construction materials. The insulating box of cargo tank number 1 is currently under construction. There are 500,000 parts involved in constructing the insulating layer. The insulating box alone has 55,000 parts of 1,100 different varieties. This is an immense operation. The construction of the insulating boxes is a challenge to the stamina and the skill of the workers. They need to transport boxes of different specifications to their designated positions. Each box has been carefully calibrated to ensure absolute evenness. The surface unevenness of the insulating box cannot exceed 0.15 millimeters every square meter. Otherwise, the Invar layer that will be laid on top of it will become uneven, and that will affect the welding process later. This is Hongqiao Li. He is the manager of the insulating box installation team. He is also the first person in China to be part of the construction of a supersized LNG carrier. In 2004, he worked in an overseas shipyard, installing insulating boxes.
After working there for 3 years, I liked the way we worked back home better. At that time, I heard we were building our own LNG carrier. I have the experience. I've worked on 3 of these LNG carriers so far, so when I heard that, I decided to return home immediately.
1, 2, 3, yeah!
At the time, nobody in China had the experience of working on an LNG carrier, so an experienced technician like Hongqiao Li was very important. Based on his experience abroad, Hongqiao Li implemented a list of improvements in the installation of the insulating boxes. This reduced the installation time by half, greatly aiding in the speed of construction. In cargo tank number 3, the workers have begun laying the Invar membrane. A frame is first fastened onto the insulating box. This frame fixes the Invar membrane onto the box.
Move the plate to the left.
Next, the workers will start to install the Invar plates onto the frame. These plates will cover the entire inner wall of the cargo tank. Their installation requires the coordination of many people to ensure that they do not break or crack. Once the Invar plates are installed, they are welded together immediately. This process requires skill and precision. The thin Invar layer is stuck close to the wooden insulating box, making it hard to weld. If the temperature of the welding flame is too low, or if it is welded too fast, it might leak. If the temperature of the welding flame is too high, or if it is welded too slowly, the insulating box behind the Invar might burn.
We have to be extremely careful when we do the welding. If there's some debris in there or if the parameters are not right, we might damage the Invar layer.
For an LNG carrier, its cargo tank needs to be completely sealed. There mustn't be a single leak, or else the entire ship could go up in flames.
If there's a leak, the liquefied natural gas will suddenly expand up to 600 times its size. Once it meets room temperature, it'll explode and cause the rest of the ship to explode. It's extremely dangerous.
Sebastian Lamorgan has been working in this shipyard for a year now. As the third-level quality inspector, his role is to look for problems that people do not see. Since the first LNG carrier was built in 1954, safety has always been the top priority in its construction. So far, there hasn't been a single leak in any of the carriers. This LNG carrier, specially made for Shanghai, must be no different. Its construction requires the utmost standards and a strict 3-tier quality control system. The quality inspectors at every level need to ensure the absolute safety of the ship. To ensure consistency in welding quality, automated welding robots have replaced human welders.
There's about 130,000 kilometers of welding to be done on this LNG carrier. More than 90% of it is done by robots.
Robots solve a lot of problems, but they cannot do everything. They can't weld in tight, irregular corners. These have to be welded by specialized Invar welding technicians. Invar welding is the most difficult form of welding in the world. To weld Invar on LNG carriers, one has to be certified by the patent company GTT and obtain the highest level G license. Only after obtaining the G-level license can an Invar welder go to work. Li Fenzhou is one of the super Invar welding technicians. She is working on the welding of the tank ceiling. This is the most difficult area to weld in the tank.
To weld Invar, you have to be extremely careful because the plates are very thin and fragile. You need to have patience and need to take it one step at a time.
In 2004, she left a small town in the middle of China to come to Shanghai. After undergoing rigorous training, she became one of the first Invar welding technicians in China. In China, 240 million people have left their hometowns to seek employment in the big cities. They have become an important driving force in China's industrialization. All of them are trying to seek a better life with their own two hands. Li Fenzhou is one of them. Now, Li Fenzhou has settled down in Shanghai. Not only has she found a job in which she works very hard, she has also found love. Her husband is also working on this LNG carrier. Their greatest dream is to buy their own place together and to send for their young child to live together with them. The supersized LNG carrier has been berthed at dock number 7 for over 8 months now. The insulating layers for all 4 cargo tanks are nearing completion. The workers are waiting for the last and most crucial component to be installed, the pump tower. The pump tower is the core component of LNG storage in the carrier. While the ship is in motion, it collects the vaporized material to provide fuel for the ship, reducing the risk of combustion. But the installation of the pump tower has run into an obstacle. The shipyard in which this LNG carrier is being built is located by the Huangpu River in Shanghai. This is also the birthplace of modern China's industry. It is also the birthplace of China's shipbuilding industry. But after a century of development, shipyard space here is running out, leaving very limited space for new projects. The shipyards are building new dockyards and piers that will provide better facilities for shipbuilding. But Shanghai's need for natural gas is urgent and pressing. The construction of the LNG carrier has to be completed soon. The pump tower is supposed to be installed in 3 days' time, but this carrier needs to be moved elsewhere. Dock number 7 is located on the Huangpu River. The average depth of the Huangpu River is 8 meters. It can accommodate huge ships weighing thousands of tons. But every year, the river transports large amounts of silt from upstream. The silt deposits accumulate and raise the height of the riverbed. This is extremely dangerous. The river is now not deep enough for this giant ship. The pump towers weigh 36 tons each. When the 4 pump towers are installed, the ship will sink by 1 meter. At the present depth of the river, this might result in the ship being grounded. "500 meters away at dock number 8, the riverbed is frantically being dredged. The workers need to dredge away 300 meters of the riverbed urgently so that the installation of the pump towers on the LNG carrier can take place here. At the other end of the shipyard, final adjustments are being made to the pump towers. This pump tower is 30 meters tall and weighs 36 tons. It is entirely made of Invar.
The special thing about it is that it's still functional at minus 162 degrees Celsius. This is very significant, and that's why we use this material for the entire pump tower as a safety measure. It ensures that the pump tower will still function even at minus 163 degrees Celsius.
The LNG carrier is being moved to dock number 4 so that the first pump tower can be installed on it. As time progresses, the workers get more nervous. The Invar membrane in the 4 cargo tanks is almost complete. It has a surface area of tens of thousands of square meters and a thickness of 0.7 millimeters. The 36-ton pump tower will be hoisted into a small opening in the top of the cargo tank and welded to the bottom. If it scrapes against the welded surface of the Invar wall of the tank, it might cause damage to the cargo tank. The tank might have to be completely refitted, resulting in a huge loss for the shipyard. Another problem is giving Engineer Lee stress.
We need to be careful about the height. The ship is dependent on the height of the crane. Because the pump tower itself is pretty tall, we'll need to watch the height at which the crane lifts it. We need to take into consideration the height of the tide and the length of the steel cables. Everything has to be carefully calibrated.
The pump tower to be installed is 29 meters tall. Taking the ship's own height into consideration, this is going to be a challenge. Under normal tide conditions, this would be impossible. The only solution is to install the pump tower when the tide is low.
This only happens a few days a month, and for a few hours each day. We'll need to install everything in about an hour. That's why you need to be very prepared beforehand.
The workers need to install everything within the hour and a half that the tide is low. All the timing should be precisely calculated. The cover of the container is being opened now. The clock is ticking.
Most importantly, I need to get out safely and flip it vertically with the crane.
The workers tie the ends of the pump tower with the cables from the level luffing crane in their designated positions. Every single hoisting position has been precisely calculated on the computer beforehand. The pump tower is slowly lifted out of its container. In midair, the crane flips it vertically. The workers quickly do a final round of inspections and cleaning before it is placed in the tank. The pump tower is slowly raised into position and moved towards the small opening. This is the most difficult part of the process. The pump tower must enter the tank through the small hole. The insulation in the cargo tank is complete. If the pump tower collides with any part of the tank, the insulation of the entire tank will have to be redone. This will result in an inestimable loss. Manager Zhao's role is to direct the crane to the opening. He cannot fail now.
A bit higher! A bit higher! You over there, come back! Okay, back it up. A little more. Keep going. A little more.
They are now halfway into their allocated time. The pump tower needs to enter the cargo tank before the tide rises.
Back that way, pull it back that way. Yeah, there you go. A little bit more, that's enough, stop.
The river is starting to rise again. The pump tower successfully enters the cargo tank through the opening. But now there is another problem. The crane operator cannot gauge the distance between the pump tower and the bottom of the cargo tank. Everything now depends on the engineer's directions. The crane operator must rely on directions given through his walkie-talkie to judge the remaining distance. Whether or not the pump tower is successfully installed depends on how well they work together.
Get into your positions. All right, go on. I'm ready. Okay. All right, you walk over there. All right, here we go. Okay.
The lowest point from above is 450. It is still within our calculations. We've chosen the time when the tide is at its lowest. We only have a small window to do this. We need to install the pump in this time. The next one is that position over there. Over there. That's a bit small. It needs to fit in there perfectly, so we're a little nervous. Today went pretty well. Pretty well, I should say.
The pump tower is finally in its correct position. Construction on the LNG carrier is seeing the light at the end of the tunnel. Over the past 2 years, 6,000 large steel plates, 350,000 liters of paint, 250,000 meter pipes, 1 million working hours, and $200 million went into the construction of this supersized LNG carrier. In the days ahead, the LNG carrier still needs to be tested out at sea before it can join the family of LNG carriers around the world. Over the next 20 years, this supersized LNG carrier will cross the oceans of the world to bring environmentally friendly energy to the people of Shanghai.